So here are some samples from section 7-4. Just some more problems if you're getting stuck on the work. So this is number 20, log base 8 of 4 plus log base 8 of 16. So the key thing is, I'm going to show you different ways you can do this. What they wanted you to do is do these mostly by mental math. And so remember, addition can be rewritten as multiplication. So this becomes log 8, and we go 4 times 16. So that becomes log 8, and 4 times 16 is 64. Then if we use the mental math, we rewrite this using exponential form. 8, because we're trying to find out what this is, to the x power. Remember, base, exponent, answer. And then we want to write 64 in base 8, which would be 8 squared. Since the bases are the same and they're equal, therefore the exponents have to be equal, so x equals 2, and so we know that this is equal to 2. So this is how they want you to do them. There are other ways you could do it. You could, when you rewrote it here, and you got log 8, 64, you could go to the graphing calculator, and remember we can do the change of base formula, and put it in base 10 since the calculator does that. And remember, in base 10 we just don't put a base, divided by log 8. And if we go to the calculator, so we go log 64 divided by log 8, and you can see we get 2 that way also. So that would be 2 ways you could do this one. Next, let's do 24. 24 says log base 2 of 16 minus log base 2 of 2. Subtraction, remember, can be rewritten as division. So log 2, 16 divided by 2, which becomes log 2 base 8. Again, we put it in exponential form, so 2 to the x equals 8. Now I need to convert 8 into base 2, so that would be 2 cubed, and so x equals 3. And so this problem would equal 3 if we did it that way. Again, we could use the graphing calculator, and right here we could go log 8 divided by log 2 by doing the change of base formula. Log 8 divided by log 2. And again, we get 3. Other ways that you could have done this, because I can rewrite this, I can write 16 as 2 to the 4th. And this already is 2 to the 1st. Remember, if this is the same as this, it equals the exponent. So this becomes 4 minus, because these are the same, it becomes the exponent, which is 1. And so 4 minus 1 equals 3. So again, in all cases, we get 3, no matter which way we do it. (26). 26 says log 2, 16, 3. So here's where we want to use the rule. Remember, we can move this exponent out front and rewrite it as p times the log of base b to a. So what we're going to do is move this 3 out front and rewrite it as 3 times log base 2 of 16. Now we have a couple ways we can do this. From here, I can write 16 in base 2, so that becomes 2 to the 4th. And because these are the same, this becomes 4, and 3 times 4 is 12, and so the answer is 12. You could have also gone to the graphing calculator here and done log 16 divided by log 2. And you get 4, and 3 times 4 is 12. So that's just another way you could have done that problem. So that's number 26. Okay, let's do 28. So that's log base 5 of 125 to the 1/3 power. So again, this is like the last one. We can move the exponent out front and go 1/3 times log 5 of 125. Then I can convert 125 into base 5. That would be 5 to the 3rd power. So because this is the same as this, that becomes 3. And 1/3 times 3 is 1. Again, you could have used the graphing calculator here and gone log 125 divided by log 5. And gotten the 3 that way, and 3 times 1/3 would be 1. So again, just two ways you can do that one. 30, 3 log base 3 of 4.52. So on this one, here's where you want to remember that if the logarithm is in the exponent, and this base is the same as that base, it's just whatever follows. And so that would be 4.52, and so there's not much to do on that. And the last one I'd like to go through is number 32. And that says log 1/2 of 16. So again, a couple ways I could do this. What they wanted to do is do this on the calculator and just use the change of base. And go log 16 divided by log 1/2. So if we do that on the calculator, log 16 divided by log 1/2, you get -4. So that's one way to do it, and that's what the book wanted to do. You could have put it in exponential form and said 1/2 to the x power equals 16. Then we would want to write these in the same base. Well, I can write 1/2 as 2 to the -1 power. And so that becomes 2 to the -x. And I can write 16 as 2 to the 4th power. And because the bases are the same, the exponents have to be equal. So -x equals 4. And so x equals -4. So that would be another way to do it. You could have done it as base 1/2, but you would have had to do this as 1/2 to the -4th power, and you'd still get the same thing. So that's just a sample of some types of problems, so that if you need refreshing, hopefully that helped out.